Hi everyone. This is the two variable system word problems guided notes. Our learning target, I can solve a two variable system word problem. Okay, so basically what this first paragraph is saying is as long as you know how to solve a two variable system, okay, so those are problems that we have previously solved using the graphing by hand method, graphing with technology, substitution, elimination, or Cramer's rule, you can solve a two variable system word problem. The only challenge that um, we will have once we're getting started is actually coming up with our equations. Okay, two variable system word problems, we are not given the equations outright. We need to interpret what our question is asking, write down our two variable system, and then from there it's just solving using whichever method you prefer. Okay, so to do this, we're going to hop right into an example. Okay, so down here in bold, we have Mr. Grover and Mr. Flynn each improved their yards by planting tulips and sunflowers. They both bought their supplies at the same store, Mr. Jake's florist shop. Mr. Grover spent $120 on 10 tulips and 5 sunflowers, and Mr. Flynn spent $156 on 10 tulips and 11 sunflowers. Find the cost of 1 tulip and 1 sunflower. So I'm going to scroll down a little bit. Okay, so when we have a two variable system, obviously we have some variables. Okay, so what we're going to do is we're going to define what those variables are. Okay, so some useful information here. We've got tulips and sunflowers in both equations. Okay, so how about we use the variable t for tulips, and we'll use the variable s for sunflower. If you're someone who prefers to use A and B or X and Y, for example, that's completely okay too. But just make sure you're defining what your variables are. So if you have X and Y, you're telling me that X is your tulip and Y is your sunflower. Okay, so if we take a look at our two equations, okay, we know we're going to have some amount of tulips plus some amount of sunflowers are going to be bought for a total cost of $120. Okay, so if we take a look at this equation so far, we've got tulips and sunflowers. When we add them together, it's going to be $120. Okay, but if we take a look at the information for Mr. Grover's equation, okay, we've got Mr. Grover here, the arrow's pointing to his equation. Okay, he didn't just buy one tulip, which this is signifying, he bought 10 tulips. So we need to put a coefficient of 10 in front of our t. And he bought 5 sunflowers, so we're going to put a 5 in front of the S. So now what this is saying is we had not one tulip, but 10 tulips that were purchased here, and we're adding 5 sunflowers, and the cost is $120. Okay, so now for my equation down here, with awesome Bitmoji, we can do the same exact thing. So we bought some amount of tulips and some amount of sunflowers, and the total cost was $156. Okay, so now to figure out what amounts of tulip or what amount of tulips and sunflowers I actually bought, we go back up to our equation and we see here that I bought 10 tulips and I bought 11 sunflowers. So those are going to be my coefficients of my variables. Okay. So if you take a look here, we actually have a two variable system of equations, okay, with our variables being t and s. Okay. So taking a look at this right here, it really doesn't matter which method you use. You should get the same answer, but if you do it correctly. But taking a look at the format of this, these are both in standard form, meaning our variables are both over on the same side of the equation. Okay, it's going to be a little bit of work to do substitution, so I'll probably try to avoid using substitution. Graphing by hand will also require a little bit of manipulation, so I'm not going to graph by hand either. Typically, my go-to is the elimination method. Okay, so that's what I'm going to do here. So if I zoom into these two equations, okay, what I am going to do is I am going to pick a variable to eliminate. So when I'm picking my variable to eliminate, remember I'm looking for coefficients that are the same number with opposite signs. Okay, so taking a look at my t's, I've got 10t and 10t. Okay, if one of these were negative 10t, I would be able to eliminate my t. So what I'm going to do is I'm going to multiply this top equation by negative 1. And I'll write the result right next to it over here. And then what I'm going to do with the Mr. Flynn equation, or the bottom equation, is I'm just going to bring it over to the side here, kind of rewrite it. So for the top, if I distribute the negative 1, I get negative 10t minus 5s equals negative 120. And for my bottom equation, it's not going to change. I've got 10t plus 11s equals 156. Okay, so what I'll do now is I will prepare for the elimination process. So when I do that, negative 10t plus 10t is going to eliminate. I've got negative 5s plus 11s, which is going to be positive 6s. And we have negative 120 plus 156, which is going to be a positive 36. So what I can do here at this point is I can get that s isolated by dividing both sides by 6. 6's cancel on the left side, and I am left with s equals 6. Okay, and we'll get to what that means a little bit later. Okay, so since we know that s equals 6, we know that we can take this 6 and plug it in for s in either our original top or bottom equation and solve for t. Okay, so what I'll do is I'll use the top equation. So for my top equation, I have 10t plus 5. Instead of s, I'm plugging in 6, equals 120. Okay, 5 times 6 is going to be 30, so I get 10t plus 30 equals 120. At this point, I know I can subtract 30 on both sides. Okay, 30's cancel on the left side, and I am left with 10t, scroll down a little bit, equals 120 minus 30, which is going to be 90. So now what I can do is I can divide both sides by 10. They cancel on the left side. And on the right side, I've got 90 divided by 10, so t is going to be positive 9. So at this point, what a lot of people do is they say, okay, we've got s equals 6 and t equals 9, and it kind of in an arbitrary two-variable system of equations previously, where you weren't given a word problem, you were just given the system outright. This this was a fine answer. I preferred it as an ordered pair, but if you had x equals 6 and y equals 9, that's fine. But this is a word problem, so I'd like a real answer, okay, or a solution to my word problem, okay? So over here, I've got an example of how I would like your answers to be set up. So 1 tulip costs, so we're dealing with money. Actually, that's a little too thick. How about I go back to my old marker? So 1 tulip, we're dealing with money, so let's put the money symbol in there. And we just said t equals 9, and up above we said t is going to be our variable that represents our tulips. So 1 tulip costs $9, and 1 sunflower costs $6. Okay, so this is what your solution should look like right here. One other thing that I feel like I should address. Let's say we're going through this, okay, we have this word problem, and let's say you miss a negative somewhere and you end up getting the solution t equals -9, okay, which would mean that 1 tulip costs -$9. So if you think about what that means is you would go to Mr. Jake's florist shop, you would pull out a tulip and you would bring it up to the register, and as Mr. Jake's is checking you out, he would not only give you the tulip, but he would also give you $9. Okay, in theory, that's what -$9 for a cost would mean. So make sure the problem makes sense or your answer makes sense for the given problem. There can be situations where a negative number could be a desired result, but in this case, whenever you're purchasing something, you should not get a negative dollar amount. You're never going to go to the store and they're going to give you money out of the register, as well as the good that you are purchasing. Okay, so just be careful for that. Okay, let's move on to a couple more example problems. Okay, so first one, Mr. Murphy is selling tickets to the annual winter band concert. On the first day of ticket sales, Mr. Murphy sold 4 adult tickets and 7 child tickets for a total of $63. And then Mr. Murphy took in $121 on the second day by selling 13 adult tickets and 6 child tickets. What is the price of 1 adult ticket and 1 child ticket? So the first thing that we're going to do is we're going to define what our variables are. Okay, so we've got adult tickets and we've got child tickets. How about we say A is going to be our adult ticket, or represent our adult ticket. And it makes sense that C would be our child ticket. Okay, and now from here we can start forming our 2 equations. Okay, so I'm going to zoom in a little bit. So the first day of ticket sales, Mr. Murphy sold 4 adult tickets and 7 child tickets. So if I write my equations right over here, we know he sold some amount of adult tickets and some amount of child tickets, which resulted in a total of $63. Okay? So these ticket sales are going to be for the first day. Okay? So how many adult tickets did he sell? Well, he sold 4 and 7 child tickets. So 4 adult tickets plus 7 child tickets equaled $63. We're trying to find what these unknowns are, our adult ticket and our child ticket. Okay, this was not a very profitable day of sales, as you can see. And then the second day, okay, he sold 13 adult tickets. Whoa, go Mr. Murphy. And 6 child tickets. For a total of $121. Okay? Okay, so now we've got our 2 variable system here. okay, with our variables being a and c. So what we can do is we can now pick a variable to eliminate. So if I take a look at my a's, I've got 4 and 13. 4 does not go into 13 evenly, which means I would have to scale my top equation and my bottom equation. If I take a look at my c, 7 doesn't go into 6 and 6 doesn't go into 7. So that means I would have to scale both of those equations as well. So how about we try to eliminate the a? So I'm going to try to find the lowest number, the smallest number that 4 and 13 both go into, okay? And I think the answer is going to be 52. So what I am going to do is I'm going to multiply this top equation by negative 13. And I'm going to multiply this bottom equation by 4. Okay, so I'm going to scroll over a little bit. So when I do this, negative 13 times 4a is going to be negative 52a. Negative 13 times 7c is going to be negative 91c. And negative 13 times 63 is going to be negative 819. Okay, and for my bottom equation, I've got 4 times 13, which is going to be 52a. 4 times 6c is going to be a positive 24c, so plus 24c. And 4 times 121 is going to be 484. Okay, so I am ready to eliminate my a. So now I've got negative 91 plus 24, which is going to be negative 67. And then can't forget my c. And then I've got 819, negative 819, plus 484, which is 335, negative 335. Okay, so now what I can do is I can divide both sides by this negative 67. So negative 67's cancel on the left side, and on the right side we are left with c equals negative 335 divided by negative 67, which is going to be a positive 5. Okay, so now we know that we can take that 5, since we know that c equals 5, pick one of our original two equations, plug 5 in for c, and solve for a. Okay, so what I'm going to do is I'm going to use the, let's use the top equation. So top so I've got 4a plus 6. Instead of c, I'm going to plug in a 5 equals 63. So if I simplify, I have 4a plus 30 equals 63. I can subtract 30 on both sides. Oh, sorry, I'm seeing an issue as I'm going through this. I was just thinking to myself, this is going to work out well. So my issue right here is, it is 7C. I was taking a look at this 6C down here. So that's a good lesson. Make sure you're being really careful or else you're going to make some mistakes. There we go, much better. Sorry about that. So we've got 4A plus 35 equals 63. We'll subtract 35 on both sides. Now we're back on track. Sorry about that, everyone. Okay, so our 35s are going to cancel. So we end up with 4A equals 63 minus 35. So I know 63 minus 30 is going to be 33, and 33 minus 5 more is going to be a positive 28. So now I can divide both sides by 4. So A is going to be 28 divided by 4. So A is going to be 7. Okay, so remember, I don't want you to leave your answers just like this. I'm just going to draw an arrow so we know where we put that 5. I don't want your answers as C equals 5 and A equals 7. Okay, I want your answers as an actual sentence, something that makes sense. You're defining both of them. So we know that one adult ticket is going to cost $7 and one child ticket is going to cost $5. Okay, so not only did we learn how to solve a two-variable system word problem, we also learned a valuable lesson about making sure we're copying down our equations correctly and plugging the numbers in appropriately. Okay, so make sure we're always going back and we're double checking our work. Another thing that we could do is we could plug our 7 in for A and our 5 in for C into the top and bottom equation, and we should get 63 equals 63 up top, and we should get 121 equals 121 down bottom. Just another way to check your work. Okay, so I'm going to scroll down. So this next one, Sunday River is a popular senior trip destination. This year, the senior class at Biddeford High School and the senior class at Thornton Academy both planned trips there. The senior class at Biddeford High School rented and filled 12 vans and 14 buses with 588 students. Thornton Academy rented and filled 6 vans and 11 buses with 438 students. Each van and bus carried the same number of students. How many students can a van carry and how many students can a bus carry? Okay, so the first thing we need to do is we need to define our variables. So how about we do V equals van and B equals bus. Okay, so we're going to have two different equations. Okay, we're going to have the BHS equation, and we're going to have the Thornton Academy equation. Okay, so the Biddeford High School equation, there were 12 vans, so 12V, and 14 buses, for a total of 588 students. The Thornton Academy equation is going to be 6 vans and 11 buses, and they had 438 students. Keep in mind this is a hypothetical situation, so there are, or not in the near future, I can't imagine, unless there's some sort of baby boom, is there going to be 588 students in the Biddeford High School graduating class. Okay. So I'm going to take a look at which variable I should eliminate. So if I take a look at my V's, I've got 12V and 6V. Well, 6 goes into 12, which means I can just scale this bottom equation. I can get away with it without having to scale the top. So to make this 6v negative 12v, I need to scale by negative 2. Okay, so I'll scroll over a little bit. So for my new equations, up top I am sticking with that one. So I've got 12v plus 14b equals 588. That's not changing. And down bottom, negative 2 times 6v is going to be negative 12v. Negative 2 times 11b is going to be negative 22b. And positive 438 times negative 2 is going to be negative 876. Okay, so now I can begin the elimination process. So 12v minus 12v, that will eliminate. 14b minus 22b is going to be negative 8b. And now we've got 588 minus 876, which is going to be negative 288. So we can divide both sides by negative 8. Negative 8's cancel on the left side. And on the right side, we are left with b equals negative 288 divided by negative 8 is going to be a positive 36. Okay, so now we can choose the top or bottom equation. We can plug the 36 in for b and solve for our v. Okay, so how about we do let's do the bottom equation this time. Switch it up. So if we use the bottom, we've got 6v plus 11 instead of b, we've got 36. So we took this number here and we plugged it in next to our 11 in for b equals 438. So if I keep simplifying here, I haven't touched my 6v yet. 11 times 36 is going to be 396. And then my 438, which I have yet to touch. So now what we can do is we can subtract 396 on both sides. So when we do that, .396s are going to cancel on the left side. And on the left side, we're going to be left with 6v equals 438 minus 396, which is 42. Divide both sides by 6 to isolate our v. So v is going to be 42 divided by 6, which is 7. Okay? So if I scroll over, again, I don't want your variable equals some number. I want you to give me an actual solution that will be useful to me. One van can carry 7 students, and one bus can carry 36 students. Okay. At this point, we have concluded the 2 variable system word problem notes. If you're comfortable with all this material, you are all set for some practice. Good luck with that. Let me know if you have any questions as usual. Thanks, everyone.